Good afternoon. My name is Diana Contreras. I'm lecturer at Cardiff University and visitor researcher at Newcastle University for the project Learning from Earthquakes. Today I'm going to present how social media and crowdsourcing platforms support earthquake reconnaissance. In work package 5 of the project Tool Development and Workshop, we use social media for earthquake reconnaissance. Pictures in Twitter and Instagram are not georeferenced anymore due to privacy issues. Then, to be able to locate the image, we look at landmarks, we check the name of the streets, and we contact the photographers to later validate the location of these images using a street function from Google Maps. In this way, it was possible to have the spatial distribution of the damages in Zagreb and surroundings. So far, we have georeferenced 39 pictures. Here we can see only a sample, and we see that the damages were concentrated on the city center. Then we make a zoom and see the location of the damages portrayed by Twitter and Instagram users. And finally, we can see a sample of the tweets and posts uploaded with the pictures. In the case of the 2020 Aegean earthquake, we have two sources of data. In the case of Twitter, based on the hashtag that you can see on the screen, we collected this number of tweets. The 33% were original, while the 66 were retweets. The second source of data was LastQuake app, a crowdsource-based earthquake information that allowed eyewitnesses to share information about earthquakes they felt, combined with seismic data. This app was developed by the European Mediterranean Seismological Center. They provide us with this number of comments. After processing, we add with this number of comments. Image and text data were collected and submitted by LastQuake app users through the app. The European Mediterranean Seismological Center storage that data. They provide us with a CSV file that we turn it into an Excel file. We process the data. Given the number of tweets, we were able to do a supervised classification of the data into polarity and topics addressed by LastQuake app users on their comments. The database with the classification is already available in the data repository of Newcastle University, and the spatial distribution of the polarity and topics can be already observed on the maps. In this map, we can observe in detail the spatial distribution of the polarity, and we can see that the negative polarity is mainly along the coast and the island when the impact of the earthquake and tsunami was most. In this slide, we can appreciate also the spatial distribution of the topics addressed by LastQuake app users in their comments, and I would like to highlight the building damage that we can observe along the coast, the reports of lifeline affected that we can observe in this point, and the report of tsunami effects that we see mainly on the islands and on the coast near to Izmir. Limitations: lack of georeferenced data on Twitter and Instagram due to privacy issues, lack of training of social media users to provide useful information for earthquake reconnaissance describing damages. Cleaning and processing data is time-consuming if we want to obtain a reliable and supervised classification. We need more data to validate our classification rules and topic identified. The accuracy of the classification algorithm for the case of the 2019 Albania earthquake was 63%. However, it's still okay because accuracy above 50 is considered acceptable. Future development. We expect to continue collaborating with the European Mediterranean Seismological Center to have georeferenced image and text data after earthquakes collected through its LastQuake app. We need to train users to provide useful data for earthquake reconnaissance, and in this way reduce the time necessary for cleaning and process data. This costs our classification rules, and identify topics with experts in earthquake reconnaissance, emergency response, and early recovery, and to increase the accuracy of the algorithm for unsupervised classification to automate the process of extracting meaningful information from unstructured data. Thank you very much for your attention.